Feeling thirsty for knowledge? Hackers on the Rocks is the podcast that mixes refreshing conversation with potent cybersecurity insights. Serving up these insights with a twist, we pair a different software vulnerability with a refreshing cocktail recipe each episode. All right, today we have a three-part conversation with Woosun Song. Woosun was a member of Team Atlanta, which notably won DARPA's AIxCC competition at 2025 DEF CON. So we're going to talk about that. Outside of the competition, Woosun, now get this, he was able to manipulate time itself and use that to drain cryptocurrency wallets. I definitely think you're going to want to stick around for that. And while headhunters are pretty aggressively pursuing all of the AIxCC team members, today's guest has opted to form his own company. So stay with us to the end and learn a little bit more about QED audit. All right. Hello, world,
Hello,
and
Evan.
greetings
Thanks.
all around. Woosun, my friend, welcome to Hackers on the Rocks. We have a lot to get to today. Let's start with a drink. What are we drinking?
We're having this thing called Havana Club. It's a Cuban rum. It's dark brown. I have it in my cup because I'm at the office. You can't probably see it in this angle. It's kind of simmering over here.
Yeah.
Yeah, it's a brown, dark Cuban rum. I love the
All right.
sweetness of rum, so we're having it today.
And are you buying this as its own entity, or are you mixing ingredients together?
I just like to have it on its own, so I'm
Yeah,
just
fair enough.
yeah.
Well, I will match as we do on the show. So stand by. I actually have some rum left over from our episode with Dr. Dane Brown, who did I think a Jamaican rum punch was the episode. So this is going to be particularly strong. And I believe, if I understand correctly, we take the rum and we kind of mix in a little bit of dry vermouth. And now we
Yeah,
have a
that's right.
Havana Club. My friend, cheers.
hmm Cheers. Yeah, it's in a coffee cup.
Of course, for those who are on the audio only feed, we have a very classy paper cup in the office, as one does when they drink in the office, apparently.
Yeah.
Um, yeah, let's get started. Let's talk about this competition. This competition made a lot of headlines. DARPA took over the CTF floor at DEF CON, had huge prizes, huge fanfare. Some of the pictures were amazing. I mean, just the layout, the logistics, the posters and everything. Like, can just I don't even know that I have a question. Like, can you just maybe tell us about the competition, the format, the rules, the experience?
Yeah, of course. So to give you a background, the name of the competition is DARPA AIxCC, which is an acronym for AI Cyber Challenge. And previously, DARPA has hosted a lot of these competitions so that private sector companies can show off their skills in various sectors. There was the DARPA robotics competition in the early 2010s. There was something called the DARPA CGC, which happened before the emergence of LLMs. It was also about automated hacking. And during those times, because LLMs weren't around, a lot of the traditional techniques were employed, traditional program analysis techniques. And now that we have LLMs, DARPA thought of hosting a competition where AI agents compete to find vulnerabilities. And it was that marked the start of DARPA AIxCC in 2024, where we had the semifinal round. And in 2025 summer, we had the final round. Um, so I think this was a 2 years worth of effort, and I'm very happy that Team Atlanta got first place in the final round. Um, yeah, so I guess that's pretty much it.
Yeah, and when I think of your classic DEF CON CTFs, right? What I'm thinking of is, you've got like a small representation of the team on the floor, and like the secret sauce is like 7,000 people stuffed into like a rental property offsite, or not even in Las Vegas, like running it from the office or from a school setting. Is that kind of how you guys had set up, or because of the agentic nature of the competition, was that aspect not even necessary?
So to answer your question, it is true that a lot of manpower was put into the competition, but that was all before the competition. The rules, I think I didn't explain this yet, but the rules of the competition dictate that there should not be any sort of human intervention for the exact reasons you've outlined, because people might use human resources to outcompete other people in the competition. So they enforce those rules by preventing any sort of internet access during the competition so that the AI agent can't have any sort of human in the loop. So I guess we did a lot of preparing. We had a good amount of people with good amount of skill, good number of people, but we weren't able to utilize them during the competition. And it's the AI agent all alone running in the Azure environment without internet all by itself.
Super interesting. You mentioned that there were multiple rounds to get to the finals. I'm assuming your team had the ability to learn and tweak and prep and improve between those rounds, or is everything just here's the implementation and round one, round two, round three?
You're absolutely correct about that. I'm kind of surprised that you brought it up. So there were a lot of intermediate rounds, I'd say. The first one was the semifinal round, which took in 2020 for summer. That was like the first non-official um, event that we could test our implementation. And then there were these, and then the top 10 teams went on to the final. And after the finalists got nominated, there were three intermediate rounds. One in March, the second one in um, April, and then May, and then there was one right before the final. So there were four rounds, which we call unscored rounds. Basically, we get to submit our Azure image, but it isn't graded, but we get the results. So
Got
yeah, so
it.
that we don't fail from like these stupid um, errors that mess up the finals. So we get to demo our implementation before the actual scoring starts.
Got it. And can we talk a little bit about the mechanics? Right. I get that it's agentic, right?
Yes.
Machine does all of the things once the competition starts. If I remember correctly from our pre-call, the way this competition was set up was not like a traditional DEF CON CTF that our audience may be familiar with. I think there was, in this case, even though it was called a capture the flag challenge, there were no flags. Is that correct? Can you maybe explain a little bit about the mechanics of the game?
Yes, you are absolutely correct. So in a CTF challenge, you usually have to exploit a system and get arbitrary code access, most likely manifesting as a shell, and then you use that shell to read a flag at a certain location. But in our case, um, the scope of the competition didn't include the exploit, which means that as long as you crash the program, you are rewarded for it. So how do we implement a system for that? We use that by using a thing called sanitizers. I think our viewers already know what sanitizers are, but to very briefly explain them, it's a special way of compiling a program so that whenever it exhibits any sort of unexpected, unintended behavior, such as out of bounds memory reads writes, or some sort of, or for Java, arbitrary command executions, it halts the program entirely and raises a certain type of signal so that the invoker of the program can be immediately notified. Um, so, to circle back into how sanitizers are related to the challenge rules, all of our targets are instrumented with sanitizers. And as long as we trigger a sanitizer fault or error using our input, we get scored. And each different type of sanitizer um, error, I'd say, characterized by the exact code path that triggers the sanitization error and the type of the sanitization error um, characterizes a single type of bug. So if we can trigger a segmentation fault in two different code paths, they are treated as two different flags, allowing us to double score.
Got it. All right, so that talks a little bit about strategy. So if I heard you correctly, you have the synthetic elements of the challenge, where the challenge makers, the folks who put the competition together, essentially intentionally created something that had a flaw in it by design, at least one flaw in it. And from a strategy perspective, if you didn't have to gain full code execution, you just needed to crash a service. But if you were able to crash it multiple different techniques, you would score multiple times. And so perhaps looking at one service repeatedly helped your team on the scoreboard versus maybe a team that just like, we crashed the service, let's move on to the next one. Is that generally how the leaderboard worked?
Exactly. So once you find a crash, it is important to move on and try to look in other angles um, instead of trying that repeatedly over and over again.
I also liked, if I understand correctly, that the game also awarded points for unintentional crashes where the designers didn't anticipate having a particular thing crash at a particular location. Um, were those scored differently? How does that work?
I think score-wise, they are treated equally. So um, to give you a little context, as we already mentioned, as we already talked, there are synthetic bugs and there are zero-day vulnerabilities where the synthetic bugs are the bugs that the authors deliberately put in to those real-world programs like SQLite or Wireshark. Um, and these zero-day vulnerabilities are the ones that existed in their code base, regardless of the synthetic vulnerabilities that they introduced. And um, and whenever we score, so obviously because the authors wrote these synthetic vulnerabilities, they have a database of all the code locations that they've tampered with. And because of that, they can accurately identify if address sanitizer crash is related to their synthetic vulnerability. And if it doesn't, it automatically classifies as a zero-day vulnerability. And I think I kind of diverted, but to answer your question, um, if we score a zero-day vulnerability, it doesn't get any bonus points, but um, it is captured as a separate statistic. So, and it is considered a great deal of matter because of its implications. And I think Team Atlanta had the most number of 0 days. We had 5 0 days in 3 different programs in the final round. And I think that was considered like very important. That it was considered very highly. So the number of 0 days were almost treated as like a separate scoreboard. So I think it's very important, and I'm very honored and happy that our system could find that many 0 days.
Yeah, and we're going to talk about that a little bit more in the next segment when we go beyond a capture the flag, contrived, gamified environment. Are you comfortable, perhaps sharing a little bit about Team Atlanta's strategy and maybe like what made your approach superior? Because there were a lot of really good, high quality, well regarded teams. What made your approach, capture the victory for you? You think?
Yeah, so I think we can't say exactly what contributed to our win because the organizers didn't disclose all the artifacts. But in my best educated guess, I think there are mainly 2 reasons. The first one is because of strategy diversification. Um, because we had so many different experts in so many different domains, all from spanning from AI to these traditional software security testing and security methods, we could try all of the methods in our system. So in like a spectrum, I'd say, where um, the spectrum is based on how much LLM we use. So there's this one end where we don't use LLMs at all, and those strategies include techniques like just pure fuzzing or symbolic execution or concurrent execution, which falls into the more traditional um, testing methods. And then on the other hand, there's this complete reasoning-based bug finding method where we heavily use LLMs and heavily rely on LLMs to make decisions. So and we had a healthy combination of every strategy in that spectrum. And I think this diversification of how much we use LLMs turned out to be a really good decision. And for the second reason I think we performed well is because we spent a lot of time and energy into making our system robust. Um, One of the teams I think performed really well on certain tasks, but their system kind of crashed in the middle of the competition, and they had to forfeit a lot of points because of that. And I think for us, our system managed to run from start to end without those issues. And making a system run for 48 hours straight is not an easy task. And I think because we invested heavily in making sure we aggressively use all the given resources and time, we were able to such a good score.
I I want to ask. Please don't take offense to this question. It's something that you said that kind of just makes my mind wander in a weird way, but kind of roll with me for a minute on this. So, as we record the show, fairly recently, Anthropic came out with a report that said nations are like wholly leveraging AI, and if you read that report, it sounds like we're nanoseconds away from like extermination, right? The machines are going to rise and kill us all, kind of a thing. And if I heard you correctly, um, what may have made your team win is not necessarily the exploitation aspects, but more the deliberate investment in principal design strategy, exception handling, robustness. Can you maybe lend some insight to the audience about maybe the maturity, today as we record this, about AI in actual network operations?
Yeah, sure. So I'm not like a blue team expert, so I don't think I am properly qualified to say about this. But in my opinion, um, I think this question has a lot of aspects to it. But the first one is, I think, the intellectual ability of LLMs to actually perform these complex offensive tasks. I think it is. And I think the boundary, I think like it was capable of doing those things starting from Opus 4. The reason why I say this is um, it was like this breakthrough where before Opus 4 came out, we didn't really consider LLMs to be a reliable operator, meaning that we could ask an LLM a question and it would give some informative answers and we could use it in our decisions. That was way before Opus 4. I think that held for like GPT 3.5. It was capable of providing informative answers, but it wasn't reliable. We couldn't use it for um, making these critical decisions of whether or not to edit a file or execute a certain command, and it would go on and on. We couldn't use it for system administration. That's what I'm trying to say. But starting from Opus 4, we could definitely use it for system administration. And I think that changes a lot of the parameters because now we can use the LLM as like an orchestrator or arbitrator that manages the operations. And security, I think, is a problem where it is hard to come up with an answer, but it is easy to validate the answer, if you know what I mean. It's kind of like a Rubik's Cube. That means that as long as you make sufficient attempts in sufficiently diverse with sufficiently diverse attempts and answers, you will someday get to the answer. And I think with this robustness plus um, reliability plus LLM's intrinsic ability to not be bored makes it a very lethal combination.
Fair enough. Well, I'm fascinated. I think you've had a really amazing experience here. I mean, life changing for you, life changing, honestly, for the planet. Congratulations. Let's maybe move on to some practical research. We kind of teased this a little bit up at the top of the show, and even in the last segment. You have been able to leverage some of these research capacities with AI technology to identify a really, really neat logic bug. Can you talk about that a little bit?
Yeah, sure. So um, after AIxCC, I decided to apply the same set of technologies we've developed during AIxCC to other domains. And one of those domains was blockchain infrastructure. And we ran our system on these software called L1 nodes. Basically, these are network participators in the blockchain that are responsible for keeping the blockchain running. And one of the vendors that we've looked into was this vendor called Cosmos. And they implemented a software called Comet BFT. Um, it's very hard to explain very briefly what they do, but in my attempt to do it, a Comet BFT is a software that implements a Byzantine fault-tolerant validator. What that means is um, in the blockchain system, in the parameters of a blockchain, there is no notion of a centralized server. And every participant has to make a best educated guess based on what they talk to with their peers. And to do that, they have to implement a Byzantine fault-tolerant algorithm where they exchange data between peers, and based on that data, they make decisions on how to make progress. And we found a bug in one of the logic that is responsible for making progress. Specifically, um, as Evan already mentioned, we focused on not we, but our agent focused on the logic to agree on the current timestamp of the ecosystem. And in that logic, there was a fatal bug that allowed one person, one participant, to manipulate it to arbitrary values.
All right, so I'm gonna try and kind of get this set up right. So, all right, so decentralized environment, all the participants need to kind of summarize reality and establish it for themselves in any particular transaction. So you have this concept of like chaining, right? There's all these different pieces that are all kind of have to go in this weird near synchronous aspect. And so this concept of manipulating time, right? I got it, right? There's a flaw, and you as the attacker are able to say, hey, the time is now noon. The time is now, making something up like February 32nd or, whatever, right? The time is now the year 6030. What does that do for an attacker when we talk about actual implementations of blockchain technology?
So you're asking about the implications of the ability to control time, right?
Yes.
So it has huge implications. I think the first obvious one is that if an attacker sets it to, so the timestamp is managed in a 32-bit integer. And so the most obvious implication is that if you set it to 2 to the power of 32 minus 1, the blockchain can't make any progress because there's no number bigger than that. And that causes the blockchain to halt in an unrecoverable manner. That's the first most obvious implication. There's a more subtle implication that is, I think, more serious. In some blockchains, they implement interest accrual, meaning that if you deposit assets into a custodian, the custodian has to give you interest, which accrues over time, and that time is measured on the blockchain's timestamp basis. So if you can manipulate time, you can act as if you've been depositing for 1,000 years, and that would give you a huge amount of interest. And the interest comes by minting new coins, and that would mean that if you mint these insane amount of coins, you would dilute all of the other owners in the process, making your wealth go up while others' wealth go down. So it's a way of stealing from other people.
Got it. So if I heard you all correctly, right? So you have this interest bearing wallet, right? And so
Yes.
you put in $1 and it's accruing 1% a year, but you've now fast forwarded it, and it's Deltron and we're in the year 3030, and now that $1 is worth a gajillion dollars. And
Yes.
as a byproduct of the way that the currency is set up, it's not just that my interest has gone up; it's that as a result, other people's have gone down. So a flaw in really in Web3 technology is very quantifiable and very quantifiably bad for a lot of people all at once. Is that kind of the implication of your finding?
That's accurate. It
Yeah,
can impact a large group of people at the same time in serious degrees.
fascinating. Winding it back to the first part of this, can you share a little bit about like how AI was leveraged to find this? Was it some special approach? Would it have been findable by hands, or is something about the mechanism making this only discoverable because of AI?
Yeah, I can definitely talk about that. So I think I would like to first mention that this bug was introduced in 2019 in a commit, in a single commit. And that means that for 6 years, all the security reviewers of Comet BFT have overlooked this bug. And I think that's pretty fair because, first, the codebase of Comet BFT is just insanely large. Um, to actually thoroughly look through the code base, I would expect it to take a few months at least, which is not a realistic scope for a human to look at. And the second thing is, it's a very special type of software where the flow of the data isn't as obvious as other types of code. So if you think about these other types of programs where vulnerabilities emerge, like image parsers or um, JavaScript interpreters, their entry points are very evident, meaning it is very obvious to know which parts are user provided and which parts are not. However, for a consensus implementation, it is not so obvious. All of the things can be controlled in very subtle ways. Like you can sit there and do nothing, and that also qualifies as some sort of input because it can trigger the timeout handler under your control. Um, so I think it is very hard to quantify the exact code paths that the program will take. It's hard to imagine like how it will work, and therefore you need a very rigorous yet flexible method to enumerate all the various attack surfaces in the program. And I think that's our secret sauce. We use AI to analyze the program and then create a comprehensive mapping between a specific behavior we like to classify as a unit of functionality and map that to the original code base lines. And then once we have that mapping, we can enumerate each entry until all of the entries are sufficiently analyzed. And by doing that, our agent stumbled upon the entry related to setting the timestamp. And I think this comprehensiveness was the main reason why we could find this bug while it was uncovered for 6 years.
I love it. I know that segues into our final segment. I hope you're having as much fun as I am. I'm learning a ton. You've accomplished so much. And as mentioned at the top of the show, it sounds like you're catapulting a lot of these learnings and experiences into your own startup. So let's take 5 seconds to pause. I'm going to thank today's sponsor, also an AI-based startup. But then, yeah, let's hear your pitch. Let's understand what it is you've got going on next. Today's sponsor is Personum. Many security teams collect NetFlow data, but struggle to turn it into actionable detection. Personum changes that with behavior based analytics that are easy to deploy and surface real threats, fast, like an extra set of eyes. Visit personum.ai to learn more. All right, Woosun, you've got the floor, my friend. It sounds like you were able to learn a lot from the Team Atlanta experience, find some flaws in Cosmos, and applying basic tech to blockchain programs. Tell me about what you got going on in life now.
Oh, so post AIxCC, I thought about what to do. Um, there were a lot of options in my hand, but I eventually decided to pursue my original passion of doing blockchain security. I used to work for the blockchain security industry right before AIxCC. And while I was doing AIxCC, I always thought about applying the AIxCC technology to the blockchain industry. And I think this startup is a really good opportunity to do it. So the name of the company is QED Audit, and we're a shop that focuses on developing tailored offensive security agents for blockchain projects. And what that means is I think our business model is slightly different from other AI security startups. I think um, the domain expertise of human analysts are still very valuable. And instead of just abandoning all of those insights and making a generic agent that can find shallow security vulnerabilities, I'd like to project those domain expertise into a tailored security agent for each project. And um, I think so far it's going very well. Our first attempt was doing this on Cosmos, and we had a really big success in doing so. We're working with a few projects similar to Cosmos that are implementing these blockchain nodes, and I think we also had some partial success there. And we're just excited to help more and more projects get the necessary security light that they deserve. And I think I'm really happy to contribute to those things.
Yeah, I mean, I think you said it earlier, or if not explicitly, you really, I heard it, even if implied. But I think when you talk about Web3 technologies, which it sounds like QED is absolutely securing, um, you know, if there's like a flaw in like an operating system, like all right, no big deal. Like this one person might have one bad day, kind of a thing. But kind of your point of like draining wallets, like I feel like hacking can pose it like an existential threat to these things. And so I'm as we start finding more and more use cases for blockchain and anything decentralized these days, it sounds like you've made the determination that LLMs are the right approach. It sounds like, as you said earlier, on a speed basis, much more effective than a manual code audit. And maybe a question for you is, you know, LLMs are relatively new in the scheme of things, but I've been listening to vendors and all of the advertising they bring for years about like so and so monitoring detection something at the speed of cyber. And like when you think about what you're doing, why is an LLM more effective than traditional automation, which can also move at the speed of of your CPU or GPU?
Um, Let me just think about that for a little moment. I think there are mainly two reasons. Um, Both are not fundamentally related to the property of an LLM, to be honest. And I think even before LLMs emerged, I thought about these limitations. The first one is that I think the biggest problem with human auditing is not the speed or the rigor or those kind of things. I think the most important thing is complacency. And once a security analyst finds a bug, they become extremely complacent. And I can say this for sure because I have been in that path already. And LLMs aren't complacent. If you clear their context window, they are as eager as they would have been even if they have found a bug already. So you have a loyal and always eager, never complacent worker that is as good as human security reviewers. So I guess there's absolutely no reason for us not to employ it. And the second one is, I think, it's kind of like an external factor. I've seen a lot of teams, um, not a lot of teams. I think nowadays most of the developers are doing this thing called spec-driven development. They write what they intend in a markdown file, and they make Claude Code or Codex make it on their behalf. This is good and all, but it makes the development speed way too fast for a security person to digest. And because of this, I think there should be light speed security because there's light speed development.
I like that. That's a really good tagline, and it makes a ton of sense to me. We're not pushing to staging once a month anymore, right? We're making multiple code changes all the time, and having something keep up with you, I think, is I mean, that's a very sellable message. Um, Correct me if I'm wrong. You dropped out of your academic program to chase this vision down. Is that generally correct?
Yes, that's right.
Yeah. So that's extremely bold. I wish you all the success. What can our audience do today to help you along with your journey?
I'm sorry, is like I didn't get the question.
Yeah, so we're all rooting for you. Every company needs something. Every person needs something. What what can members of our audience who are hearing your story and inspired by it do to help you with your brand, with your company, with whatever needs you might have?
I think at the moment, the most important thing that we need is, I guess, attention. So, if anyone is interested in blockchain security or even just general security that is carried out by AI systems, please be interested in our work because I think it's um, it's the state of the art. It's at the horizon of AI security. I think you'll definitely be interested. So please stay tuned with our work. We have a website that We post every week, and I think all of those posts are super interesting, and you'll learn a lot from it. So please be tuned.
And what's the location of those updates? Is there a domain that you want to plug?
Yes, it's the name of our company .io. So it's QEDaudit.io without a dash. It's just QEDaudit.io.
All right, that serves up today's last call. I think we're out of time for today. Listeners, we experimented a little bit. If you liked today's 3 mini chapters format, or even if you didn't, let us know. Hackers on the Rocks is also on a journey to learn and improve and help wherever we can. Woosun Song, thank you so very much. I really enjoyed today's conversation.
Thank you, Evan, for having me today. I really
Yeah,
enjoyed it as well.
cheers.
Cheers.